Hello students. So we are discussing solutions for your competitive examinations here. Okay. See the question now. Question number 31. So some questions which are difficult, those I will discuss, and which we have already discussed in the class, means in the previous videos, and means we have already done comparative. In that one already some questions here covered, and those type of questions I will skip here. Yeah. See, roughly I will touch each and every question, no problem. Just you see here. Among the following, one that gives positive iodoform test upon reaction with iodine and NaOH. Clear? So I already mentioned here positive iodoform test for alcohol. To give positive iodoform test, and this group should be present. And here any group it group R can be here H, R can be here CH3, whatever it may be. Clear here? Now. So here in this case, if the group is having this, the compound is having this group, then automatically it will show the what it is a positive iodoform test. So that's why if you see the options here, first option it doesn't have, because CHOH is there, but both sides CH2 groups are there, so it is not. And also second option CH2OH is there, and here CH3 is not there. So in the same way, if you see the question, option 4 is the correct one. In this one, you see what is there, pH, and here CHOH, and what is there, CH3. So in this compound, which group is present here? CH3, CHOH group is there. R can be here, what it is? R can be hydrogen, or it can be alkyl, or it can be aryl, or whatever it may be. This is R. So what is the answer here? Option 4 is the correct one. Clear? Next one, 32. Check it whether CHOH, CH3 group are there or not. You just check it. On treating a mixture of two alkyl halides with sodium metal in dry ether, 2-methyl propane was obtained. Clear? So means, so two compounds, just assume compound A and compound B is reacted with, clear? React each other in presence of which one? Sodium metal Na, and gives the compound is 2-methyl propane. So what is the compound here? 2-methyl propane. This is propane, 3 carbons, and first second carbon, 3-methyl is there. Clear? So what are A and B they are asking? So the alkyl halides are. What are those? These two are alkyl halides, and they are asking what are those alkyl halides. You know, this is a which reaction? Alkyl halides and sodium. It is a which reaction? Wurtz reaction. Clear? But Wurtz reaction, it is not a cross Wurtz reaction. We can say same alkyl halides means simple Wurtz reaction. Clear? So now this compound has to form. To form this compound, you see, if I break this compound here or here, you will get the same, and break here, put one chlorine and here one chlorine, because you know that how we will write here chlorine and here sodium. And what you will write here? CH3. This is the Wurtz reaction. Same alkyl halide will get one chlorine and one chlorine, and here Na, 2 moles of NaCl will be removed. What you will get here? CH3. Means to write the products again reactants. Break here. Put one Cl to this and one Cl to this. Then what is it? These are the reactants here. Same in this way. Break this. Then what you have to write now? You have to put one is CH3CH, CH3Cl. Another one should be what it is here? CHCl, CH3. If you write here, take this 2 moles of sodium, then what you will get? And you will get the compound is, this is the compound. Means, what are the reactants here? 2-chloro. What is this one? 2, 1, 2, 3. 2-chloro. What is propane and methyl chloride? That is the answer. So option 1 is the correct one. Next one, question number 33. So in the reaction, the sequence, clear? So you are getting here DDT. Final option you see here in this one. Final compound is DDT, that is X they have given X, and here Cl2, FeCl3, clear? Then you will get here Y, and Y is treated with so CCl3, CHO, trichloroacetaldehyde. Clear my dear? Trichloroacetaldehyde. Chloral we can say. Clear ma? And it is Y is reacted with this, and you are getting which one? DDT. That is the structure DDT. Clear ma? So DDT, how it will be prepared, we have already discussed. How it will be prepared? You will get here, and you know, chloral when reacted with 2 moles of, what it is here? 2 moles of, and what it is here? Chlorobenzene. Clear ma? Simple, I will write in this way. See, this is CCl3. Shall I write C double bond O? And what it is here? I will write C double bond O, and H. This is what is chloral. And in this case, take the, this is, if you know this reaction, then very easy. Here which one is there? Hydrogen. Then which one is there? Hydrogen. And remove this. Chloral when reacted with 2 moles of chlorobenzene, you will get the DDT. What is the formula you see here? In this case, clear ma? So I will write here CCl3 and CH. One is here. This is the chlorine, and another one is, what it is? This is the. So what it is not here? It is a DDT. Means what does it should do? React with which one? Y. Y means what is not? Chlorobenzene should come. Chlorobenzene, how you will get from X? Take the benzene here, do the chlorination, then what you will get? You will get here chlorobenzene. So what should be the X here? Benzene. X should be what it is not here? Benzene. Clear? So question number 34. Question number 34. Clear? See here. Of the isomeric hexane, the isomers that gives a minimum and a maximum number of monochloro derivatives are respectively. Clear? I already discussed which one gives means monochloro derivatives. So which compound gives the minimum and which compound gives the maximum? What you have to do? Just identify how many types of hydrogens are there. How many types of hydrogens are there? Those many monochloro products you will get. Clear? No? So simple example. 2 to 4th option you see 2, 3 dimethyl butane. 2, 3 dimethyl butane. So monochlorination. How many monochlorination product you will get means how many types of hydrogens are there you see. This is all the CH3s are, you know, same type, because this CH3 is added to CH and this is also added to CH. These 2 also added to CH. So that's why all these hydrogens are same type and these 2 are different. This is B and this is B. So how many monochloro products you will get? 2 monochloro products you will get. Clear? No? So like that. And 2-methyl pentane. 2-methyl pentane means what is it? CH3 and CH3, CH2, CH2, CH2. This is 2-methyl pentane. So it gives how many monochlorinated product? How many types of, you know, hydrogens are there? This 2CH3 and this CH3 is different, right? Because these 2 are attached to CH and this is attached to CH2. So suppose A, then it is a B. Clear? This CH2 and this CH2 both are different because it is added to CH, it is added to CH3. So if it is a C and it is a D and this is different E, how many types it gives? 5 types of monochlorinated products. So the option should be remaining answer you do, you will get the answer. Clear? No? So next one. 4th one is the answer here. 35. 2-bromocyclohexane. You know, dehydrogenation gives. Dehydrogenation. What it is now here? 1,2 tribromo. Here bromine and here bromine. Dehydrogenation. Actually, it is not dehydrogenation. 1,2-dibromocyclohexane on dehydrohalogenation. It should be clear. So here in this case, and here 1 hydrogen and here 1 hydrogen. Then what you will get now? Remove this and you will get the compound is, and here 1 and here 1. So option 2 is the correct one. So 36 is, you know, predominant product. Option 1 is the 36 for option 1 is correct one because you have to do the elimination according to the Sage of rule. Clear? No? Next, structure of the major product formed in the following reaction. So see the 37th question. Question number 37. Major product they are asking. So here OH and here there is iodine and here which one? Chlorine. So NaCN and what it is here? DMF. So DMF they have given. DMF means what it is man? DMF is a polar aprotic solvent. It is polar aprotic solvent and here nucleophile. Then the reaction is which reaction? SN2 reaction. Clear no? So whatever it may be, and if chlorine or iodine should be replaced by the nucleophile. But which one replace? Iodine or chlorine? Because this bond it won't be substituted. Why? Because it is not a single bond. It is a what it is one? Partial double bond. Because it is having a lone pair and a double bond is in conjugation, so it is a partial double bond. So this iodide will not be substituted by the Cn. Only which iodide will be, which halogen will be substituted? Chlorine. So your product will be this is. Clear no? So option 4 is the correct one. Clear no? So 38th question, 1-chlorobutane and reaction with alcoholic KOH. Alcoholic KOH means which reaction? Elimination reaction. So you will get the option 1 is the correct one. Clear no? Next one, 39. The order of polarity of CH3I, CH3Br, CH3Cl molecule follows the order. Polarity depends upon electronegativity. As the electronegativity difference increases, automatically polarity increases. Clear no? So here all cases CH3 is common. So you have to consider the electronegativity of halogen atoms. Which halogen will have highest electronegativity element among these three? Chlorine. So that's why option 3 is the correct one. CH3Cl is greater than CH3Br is greater than CH3I. 41. Next one. Question number 40. Correct order of reactivity for halides is. Correct order of reactivity of halides is. Allylic halide, first one what they are doing? Allyl halide, one is vinyl halide. CH2, CH, Cl. Next one. Allyl halide. Allyl halide means what is one? CH2, CH, CH2, Cl. This is allyl halide. And another one is propyl halide. CH3, CH2, CH2, Cl. Reactivity for halides is. Clear no? Reactivity for halides is. Which one is halide is involved in the reaction very fast? Clear no? So which halide means you already know, I already mentioned allylic halides are. Means first one is benzylic and after that allylic, tertiary, secondary, primary and last one is vinylic. So that's why which one is here? Allylic comes first and this is primary comes second, vinylic because here it is less reactive. It involved in the which one? Resonance conjugation. So that's why this is one, allylic will first and primary is second, vinylic will be last. So your option should be option 3 is the correct one. Clear? Next one, 41 question. Question number 41. Direct question. This is CH3Br treated with which one? KCN treated with KCN. Clear? Potassium cyanide and alkyl halide. What you will get? CH3Cn plus KBr. Potassium means alkyl cyanides. Cyanides now reduction. Cyanides means what is the reduction? What is the reduction here? Sodium and alcohol. This is reduction, reducing agent. Clear no? So sodium and ethyl alcohol means what is here? Reduction. Clear? So what is by? Cyanides reduction. What you will get? Cyanides means what is here? CH3C triple bond N. Reduction means what it is? Addition of hydrogen. It will provide the hydrogens to this. So this hydrogen will be added here. One double bond is there and two double bonds are there. Break two double bond, two hydrogen here and two hydrogens here. CH3, CH2 and H2. Means reduction of cyanides you will get primary amides. So 41 answer option 3 is the correct one. 42. Which one of the following forms propane nitrile as a major product? What is the propane nitrile? CH3, CH2, Cn is a propane nitrile. Propane nitrile. Ethyl cyanide. When you are writing IUPAC name, this carbon should be included. So propyl nitrile. Clear ma? So direct reaction here. So what you have to take here? You have to take the CH3, CH2 in Br or Cl. You can take, that is bromine, with the alcoholic HCl. Then what will happen? You see ma here. Then what happens? Bromine will be substituted. You will get the Cl. So option 1 is the correct one. Clear ma? Next one. So compound 43, compound A and B, same question we have discussed in the competitive exam. Means when we discussed about the competitive in our books, means in the our Narayana material. So there I have discussed the 43 question, exact question. So I am skipping here. Clear no? Next one, 44. Option 43, option is 1. 43 option is what it is here? 1. It is based on Williamson's reaction. Clear? Next one. Which compound react with the ethyl magnesium bromide and water will form 2-methyl butanol? What it is here? 2-methyl butanol. Which one should react here? Ethyl magnesium bromide. You know what is ethyl magnesium bromide? C2H5 MgBr will react with compound, some compound A, and gives the 2-methyl-2-butanol. 2-methyl-2-butanol. This is 2-butanol, and here 2-methyl-2-butanol. This is clear. So in the second position, 2-methyl and 2-ol. Clear. This compound should come. Clear? You know that in this case, whenever Grignard reagent reacted with the, it is which alcohol? Tertiary alcohol. It is a which alcohol? Tertiary alcohol. I already mentioned. Whenever Grignard reagent reacted with the formaldehyde, gives the primary alcohol. Other than formaldehyde, any aldehyde is there. When it gives the secondary alcohol. And Grignard reagent with ketones gives the tertiary alcohol. Means it is a tertiary alcohols. Means A should be what it is here? Ketone. A should be what it is ketone. But you know, I already mentioned, whenever any ketone, suppose R is there, R, CO and O, this is ketone, we don't know what is that one. Now it is reacting with what it is C2H5 MgBr, followed by what it is here, hydrolysis. I already said how to write the direct product here. How to write the direct product. So what is alkyl group is there in the Grignard reagent should be added to the carbon and O should be converted into OH. Then what it is R and COH, and here R, and another one is what it is CH2. This is the product. How to write the direct product means what is the alkyl group is there. This alkyl group should be added to the double bonded carbon and O become a OH. That is the direct product. How to write? Clear? Now see in this one. And one is ethyl group. This ethyl group has come from which one? Grignard reagent. Means remaining 2R belongs to what it is CH3 belongs to here. CH3. Then what it is CH3. Then what I will get here? CH3. And here what I will get? CH3. So this is my compound. So this alkyl group is from which one? Grignard reagent. Means these two groups are belongs to ketone. And CH3, CO, CH3. That is your option is option 1 is the correct. Clear? So dipole moment are also I have given already. So fluorine should have highest dipole moment, but it won't. CH3Cl will have. I discussed already in the classroom. 46th question. Option 2 is the correct one. 45. Option 2 is correct one. Next one. 46. Which of the following chlorohydrocarbon readily undergoes solvolysis? I already mentioned solvolysis means what is the solvolysis? Solvent is act as a nucleophile, and those type of reactions we will called as a solvolysis reactions. And solvent itself it act as a what it is nucleophile, and those reactions we will called solvolysis reaction. 99% solvolysis reactions are follows the SN1 mechanism. I already mentioned this, remember. So SN1 mechanism. Indirectly they are saying it is a SN1 reaction. Which one of the chlorohydrocarbon readily undergo means involved very fast reaction in the SN1 they are indirectly asking. So what is the order you already know? What is the order now? Benzyl. Next one is allyl according to SN book. What it is here? first one is benzyl halides are more reactive than which one? Halide. And next one is tertiary, secondary, primary, and CH3Cl. Last is vinyl. This is the order. Clear? See which one is there here. The last one is what you will get, vinyl you will get, and after that you will get halide, halides, all these are. Clear? So now, if you see the third option, it is a benzyl chloride is there. So it is involved in the SN1 reaction very fast. Option 3 is the correct one. Clear? Next one. 47. Question number 47. Clear? So here 2 moles of chloroform when reacted with the oxygen. This is oxidation of chloroform. You will get the phosgene. What you will get here? Phosgene plus 2 moles of HCl. Clear? So this we will call as a carbonyl chloride, or can also be called as what it is now? Phosgene. Clear? Phosgene. Clear? And here the reaction, this reaction takes place HNO in presence of air. Means just pass the air. Oxygen comes from air, and you have to maintain which conditions? Light condition. Then automatically chloroform will oxidized. Okay. So that is question number 47. Option 3 is the correct one. Next one, 48. Clear? And now 48 question. See what they have given? Aniline they have given. So what they have given here is aniline plus NaNO2 HCl, diazotization reaction, HCl at 278 Kelvin. Then what it is, man? Aniline is converted into benzene disonium chloride. What it is, man? Benzene disonium chloride. This is diazotization reaction I already mentioned. And it is treated with HBF4, chloroboric acid. Clear? What is this reaction? I already mentioned. Boltzmann reaction for the preparation of what it is, man? Chlorobenzene. It is already given in your notebook. Just once you can go through that one. So then what you will get, man? You will get clear? Fluorobenzene. So what is your answer? Option 3 is the correct one. Clear? Next one. 49. Question number 49. So identify X and Y in the following sequences. What is the X and Y they are asking? C2H5Br. Clear? So next you will get some product P here, and X, and the next Y you will get C3H7NH2 there also. Clear? So here whenever you just remember, with the bromine you are getting amines with increasing one carbon atom, means definitely and cyanide group should be added. Clear? So that's why your X should be KCl. Then what you will get by here? Cyanide will be added C2H5Cn. C2H5Cn. And now to come NH2 means you have to add what is hydrogens, means reduction you do. Do the what it is reduction. Yeah. So here so many reducers, they have very good reducing agent is lithium aluminum hydride. It is a powerful reducing agent, and it reduces this compound to, see here 2 carbons are there. This is becomes CH2 and NH2, then C3H7NH2. This is, so what should be your answer here? Your option should be 49(1). Clear? Next one, 50. See the question number 50. So chlorination of toluene in presence of AlCl3. Chlorination of toluene in presence of AlCl3, Cl2 and FeCl3. Chlorination. Toluene is a which group? Alkyl groups are electron donating group. When electron donating groups are present on the benzene ring, they act as a ortho and para directing group. Then chlorination if you do, you will get the compound here CH3Cl and ortho chloro, and another one is what it is? Para chlorotoluenes you will get. And followed by treatment with the NaOH gives. Means NaOH, but you have to maintain very drastic conditions here, then nucleophilic substitution takes place. Otherwise it won't take place, then you will get the compound here is CH3OH, and another one is what it is? CH3OH. This is cresol. CH3 and OH is there on the benzene ring, that we will call as a cresol. This is orthocresol and it is a paracresol. Remember, this reaction will not take place easily because here this bond is not a single bond. It is a which bond? Partial double bond. So you have to maintain very drastic conditions. Then only this reaction takes place. So you will answer is mixture of orthocresol and paracresol. Clear? Next one. So next one is 51, question number 51. So they have given this question based on what it is about boiling point. Primary, secondary and tertiary alcohol boiling point. Very nicely we have explained in the PE class, means that is in the when we discussed about the PU part, there we have discussed. Primary alcohols will have high boiling points than the secondary and the tertiary. Primary means surface area will be as the means secondary and tertiary. Then what will happen? Branching increases. As the branching increases, the van der Waals force of attractions decreases. Then automatically boiling points decreases. Clear? So that's why if you are moving from the primary, secondary to tertiary, branching increases. When branching increases, van der Waals forces of attraction magnitude also decreases. So boiling points decreases. So that's why primary alkyl halides will have high boiling points compared to the what it is secondary and tertiary. So your option should be option 4. Clear? So next one, 52. So this is question, same type of question here. Aniline they have given, clear? Aniline. So plus, this is bromine, bromination in water. Clear? OH minus they have given actually. Clear? It is bromine in water. It should not be actually OH minus. Here should be H2O. Then means in the polar solvent we are adding here bromine. So NH2 is a highly active group, means highly electron donating group. So it activates the ortho and the para position very high in extent. So that's why without any FeCl3 and AlCl3 catalyst, and here you will get the compound like NH2, bromine, and bromine. Like phenol. Phenol in bromine water, what you will get? 2, 4, 6 tribromophenol. In the same way, NH2 if it is there, 2, 4, 6 tribromophenol you will get. Clear? So next one is this they have given next NaNO2 and HCl. What is this reaction now? Whenever primary amine Na2 and HCl, then what you will get now? It is a diazotization reaction. Then we will get the compound is benzene diazonium chloride. NH2 group will be converted into diazonium Br, and here what it is now Br, and this is reacted with chloroboric acid. Just now only mentioned. And when chloroboric acid is there, then nitrogen will be, means it will be removed in the form of N2, and fluorine will be bromine, and what it is now? So here option 1 is the correct one. Clear? Next one. Question number 53. Question number 53. Clear? So they have given question here CH3Br plus Nu. Clear? You will get CH3Nu plus Br minus. Clear? So the decreasing order of the rate of above reaction with the nucleophiles they have given. What is the nucleophile here? PHO minus, and here CH3, C double bond O minus, and the next one is OH minus, and the next one is CH3 minus. Okay? So which one is most nucleophile there are? Nucleophile means what? It should be more electron rich. If we nucleophiles are electron rich, where the electron density is high, and that one is act as a powerful nucleophile. You see here, in this case, electron withdrawing group is there here. On the oxygen, electron density decreases. Here also, it is involved in the organism. O minus, involved in the resonance. Here, electron density will be less. So that's why. But here, electron donating group, electron density on the oxygen will be more. So electron density increases, means it acts as a good nucleophile. So it is powerful nucleophile. And the next one is this suppose if I write 1, this is they have given A, B, C, D. B is powerful nucleophile, then C. Then what you will get one? And you are getting B and what it is one here? C. Next what you will get here? B you will get, and after that finally what it is one? A. Because electron density on the oxygen atoms in this way, so your option should be option 1. Now they have given here is less than A, less than B. Clear? So option 1 is the correct one. Clear? Next one. Question number 54. See the question number 54. Simple question. This is direct question. So what it is now? OH is there, and what is PBr3? Alcohols are converted into what it is now? Alkyl halides. Clear? That is bromine. And after that, what they have given second one? Alcoholic KOH. Alcoholic KOH means which reaction? Elimination. Elimination means beta hydrogen should be removed. Then what the product you will get now? Alkene. That is option 1 is the correct one. Clear? Next one. 55. Question number 55. Clear? So 55 question, if you see, they have given C2H5Cl. C2H5Cl should be converted into C2H5OH. Clear? And then another one also is there. C2H5Cl. Another method to form the ethanol. One is there. What is it here? If I take alcoholic KOH, which reaction takes place? Elimination. But if I take aqueous KOH, which reaction takes place? No, substitution. Cl will be replaced by OH. And if I take moist Ag2O, what it is here? Moist Ag2O. Moist Ag2O means what it is? AgOH. Then OH will be replaced. Cl will be replaced by OH. You will get AgCl. Then what it is? That is the option. So your option. This is directly we have discussed. Clear? So next one, 56. Question number 56. A compound A reacts with alcoholic KOH yields compound B. Clear? So compound A, and it is treated with alcoholic KOH. Alcoholic KOH means what is it? Elimination means A should be alkyl halide to yield compound B. Clear? Alkene. B means what is it? Alkene. Which on ozonolysis followed by the reduction. Then you are getting here compound. One is methanol, CH3. One is methanol, formaldehyde. Another one is what it is? Propanol. Propanol means what it is? CH2, CH1. This is the compound. Then they are asking what is the compound? A. What is the compound? A. Clear? See now here. And you know, when they have given, I already mentioned in the class, clear? So whenever ozonolysis products, if they give, then how to write the reactant? What you have to do, man? Just to remove the oxygens here and connect these two with the double bonds. Then what you will get? B here, CH3, then CH2, CH double bond. Shall I write CH2? This is what it is here, B. Clear? Then what you have to get? Double bond you have to get. To get the double bond, and A should be what is alkyl halide. A should be what it is here? Alkyl halide. Means which alkyl halide? CH3, CH2, 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 Cl. And chlorine should be where? Primary chloride it should be. If it is there, secondary chloride means if suppose CH3, CH2, CHCl and CH2. Major product you will get this is not this one. So that's why. And last terminal carbon chlorine should be there. Put alcoholic KOH, then elimination, this product you will get. Do the ozonolysis, finally you will get this one. So 1-chlorobutane. That is your answer. Clear? So next one, 57. Same simple question. See my alkyl halide, alcoholic KOH. Which reaction? Elimination reaction. And after that HBr. HBr means what you will get? HBr means alkene HBr. Markovnikov addition. Clear? And after then aqueous KOH. Aqueous KOH means what ma? Nucleophilic substitution. Then what the product? Clear? You already know. Propane 2-ol is the product. Simple ma. So this is, you see, 57. What is the question? CH3CH2 CH2Br. This is the question. What they have given? Alcoholic KOH. Alcoholic KOH means what it is ma? Alcoholic KOH. Which reaction? Elimination. And one hydrogen here and one bromine removed. Then what you will get? Beta hydrogen always should be removed. CH. And what you will get? CH2. Then what it is? HBr. HBr means what? No peroxide. So it is a Marconi rule. And CHBr here. And you will get CH3. Then they are asking here aqueous KOH. Aqueous KOH means which reaction? Substitution reaction. And OH and CH. That is 2 propanol. Clear? 58. 1 phenyl 2 chloropropane on heating with alcoholic KOH. Main product is 1 phenyl. This is 1 phenyl. Clear? 2 chloropropane. CH2, Cl and CH3. Clear? So what is the alcoholic KOH? You know alcoholic KOH. Alcohol KOH means which reaction? Elimination. Now we have two beta hydrogens. Here one beta hydrogen is there, and here also beta hydrogen is there. So which one you should remove? The means which hydrogen should be removed? So I will write both the product. If this is A and this is B. Suppose remove here A hydrogen. Then what will you get from here? You will get the compound phenyl and CH2. CH double bond CH2. Here one hydrogen and one chlorine double bond will form here. If I remove here B, then what is B hydrogen? Then I will get CH double bond CH and CH3. Which one is major product one? According to set of rule, you know more substituted alkenes are major product. Here only one alkyl group. Hydrogens will never considered as a substituents. And here, you know, this is one alkyl group and this is one group. So two substituents. So that's why this is the major product. Or otherwise, you know, double bond, single bond and double bond. There is in conjugation. Conjugation means what? They involve in the resonance. When they involve in the resonance, they are very, very stable. So more stable product always major product. Clear one? Next one. 59. I already mentioned in the you know, this is C6H5 and H2 plus what it is here? Chloroform plus KOH. Clear? So what is the reaction here? Carbide amine reaction. This I have discussed in the alcohols actually. So alcohols is there, next amines also there. There also we will discuss. Isocyanates are the products. What are the products here? Isocyanates are. Isocyanates name what is carbylamide. So that's why we will call this reaction as a carbylamide reaction. 60. Alkyl halides are treated with suspension of dry Az2O. Very important this is. Whenever alkyl halide Az2O moist, if I say Az2O moist means what it is ma? It is in form of what it is ma? AzOH. This is aqueous solution of AzOH. Then what you will get? ROH plus AgCl. Alcohol you will get. If I take dry Az2O, then what it is ma? This is RCl. 2 moles you have to take here. This is dry. Clear? Then what will happen? You see here. I will write in this way. Az2O. Az2O means Az and O and what is ma? Az. Then what will get ma? Ethers. R and O and what is ma? R, O and R. Ethers are the product. With moist Az2O, alcohols are the product. With dry Az2O, ethers are the products. And this is about your, you know, competitive question solutions. So here, what is the option for your 60 question? So option 4 is the answer. Why? Because ethers, what are the IUPAC name? Alkoxy alkanes.